Hey guys, it's Tyler with Tracer Wire Technologies. Today we're out in the field to demonstrate the smart trace systems. All of our devices are retrofittable and have been designed for a variety of fixtures, and this particular model is the flush mount terminal. So this location appears to have 3 tracer wires and of course the ground. As we've discussed in the previous videos, low frequency is usually more accurate. The only way you can use low frequency is if the far ends of these tracer wires are grounded, and that we can directly connect to the individual tracer, the target conductors. So in this example, since there are 3 tracer wires, it tells me that there's most likely a line coming in, maybe another line going out, and then a lateral running in some direction. So let's say I wanted to locate one leg of this system starting from this location. So since the whole system has been retrofitted with our terminals, I know that the far ends of each of these legs are grounded. So I need to unground this terminal to perform the locate. So by ungrounding this terminal, I'm also isolating each of the wires from one another. Now this is really important, and I'll show you why here in a second. Now I can hook the transmitter ground clamp to the ground lug and the positive lead up to the tracer wire I'm trying to locate. In this case, it's going to be tracer 4. So there's the tracer lead and the ground terminal there. So now let's get the drone in the air, and then maybe I can show you guys from a bird's eye view what's really happening. Okay, so as you can see, I'm perfectly able to locate the desired path using low frequency. None of the transmitter signal is traveling to any of the other 2 tracer wires. This is because they're isolated from one another via the switch. Low frequency, low power, very accurate, quick and easy. Now what I want to do is I'm going to flip the switch and make all of the tracer wires common. I just want you to understand why this is not a good practice. So let me flip the switch. Okay. Now when all the tracer wires are common and cannot be isolated from one another, the transmitter signal will always seek the best ground. Soil conditions such as moisture content, alkalinity, soil type, even things like tide can greatly influence the integrity of the far end grounding. So if the grounding at, say, point B is better than at point A, my signal will go to B, and I will have a very hard time locating to point A. So by isolating all of the tracer wires from one another, and by connecting my transmitter to the intended target conductor, I'm able to ensure 100% of the transmitter signal will travel down the desired path. Anyway, I hope this helps, and definitely please consider subscribing, because we plan to release more videos shortly related to the proper locating principles. Thanks guys, we'll talk to you later.